Today, I wanted to go through some networking. While the subject isn't quite a very beginning set, it is not too crazy to work with, right? We do have a couple of options, and I'm going to try and do it in the most versatile way possible. And it's going to be really kind of like if you've seen any of my previous streams playing Greyhack, you've got this simulator, it's on Steam, and basically you're able to play a game, quote unquote. A game now is very subjective, but you're able to play a game that emulates a type of networking system. For instance, oh, did it start all over again? Okay. For instance, this is a simulator. Again, this is called Greyhack. And a couple of things we have for us is, let's see, user bin. It is running a Linux-based system. At least that's the emulation. And here's your typical networking environment, right? Oh no, it looks like I'm already connected. Good. So we're gonna try and understand how this works. And with that in mind, it's very much on the side of understanding how connections work, how ports work, a lot of pieces. So again, like wanting to be in the network programming space, it's not just programming. It's very heavy on the IT side. So we'll be learning some information technology on how networks work. And this is a very good example as far as a already configured network topology. So you've got a couple of types of devices. You've got routers that act as gateways, like doorways. And you can imagine this section here is just a room. This is a room in the case of either physical room, because they could be literally in the same room, or in my case, not so much. I'm technically hijacking my way in there. But they kind of consider themselves like a router virtual room. All of them are accessible underneath this router. But in order to go into the next room, which would be behind this router, you would need some form of connection to it. So you would have to go from the router here, find a way to access or go through it. Depending on firewalls and other kind of security measures, it can be easy, it can be hard. But then you'd have access to these other servers. But technically, because we're in this current room, I only have access to the local places. So if I was to ping 192.168.1.2, that's successful. That is right next to me and it's within the same router range. So I can access this. And again, a router is basically any device that acts as a door, which can be a wireless router. It can be a modem with a built-in router or switch. And basically anything that can connect multiple devices to a center point. And in this case, if I wanted to maybe ping over here, the 192.168.19.2, oh, that seems to be successful as well. That's not bad. That's not bad. But at some point we get blocked, especially when we change the subnet here. This is not a 192 anymore. It's a 10.0. So if I try to ping 10.0, it's still successful. Very interesting. 10.11. There might be very loose router protections on this network. Normally, you're only given access to the local space. You're not allowed to technically access other subnets. So this could be a case for just the program, the simulator itself being a little bit lenient on the capabilities, or there is an actual bridge where we can connect directly to other networks. But this one, okay, so here we go. Well, 5, that's interesting. The 5 is behind a firewall. So what about 172? Aha, so I cannot reach this device here as it is behind a firewall, but it's interesting that I can reach this. So this might be kind of an issue with the game itself. Normally, you have restrictions that you have to abide by, and the routers will separate each into their own bucket of devices. So this is what we're looking at when we're thinking about computers, phones, laptops, anything connected to a centralized network, aka your home network. In a business environment, you would have multiple routers connected to each other. But in a home network, you probably kind of have just this section here. Mom's computer, dad's computer, your computer, whatever, right? Depending on how it's set up and how many people, and a phone if it's connected. Anything that's basically connected within this section will only be accessible to each other. But then you can also throw up firewalls, which will prevent any external connections from happening. So this is the IT part of networks, right? We're going to be doing a similar factor here with coding our own server and accessing it between different devices. The problem is we essentially need multiple devices. And while I do have multiple devices, it's kind of hard to show different devices on a single stream. So what I will do is I'll also show you how you can play around with different systems, operating systems that you can install on your computer. For that, we're going to need basically virtual machines. So while this was kind of a quick show on networks in a general sense, we do want to go a little bit deeper and go into the realistic aspect of it. Python, real computers, and not a simulated environment. So I'm going to shut this simulator down. And therefore we are here. Now the first thing we'll do, we will want to grab a virtual machine. So I always like to go with VirtualBox. Very straightforward, free to use. And I kind of have to set it up again on my system. So here's how we work with this. VirtualBox is essentially an application. And there's two sides of this. There is a host computer, which is the main computer you're using. So if you're on a Windows computer, you want the Windows host. If you're on a Mac computer, you want the Mac host. But then there's also the Intel processor, which is important. And there's also the Apple Silicon host type. The processor will make a big difference between the code that makes up VirtualBox. You can also use Linux distributions. So we're gonna be kind of mixing it up a little. I'll be using some Linux distros and potentially a Windows distro as well. But for now, my host is a Windows, so I'm gonna go ahead and open up and save this sucker. And while it's downloading, we do need some other things for us to play with. We need a Linux ISO. The ISO file is a type, just like exe is a type and ISO is also a type. Now, it's interesting because we don't really use CDs anymore. The ISO is a virtual CD. It's almost reminiscent of the times where we used to own our own CDs and music and games. Everything came in a CD. You pop it into the computer, start playing whatever you're working with. Nowadays, you probably won't see a lot of computers have a CD drive, but historically, the ISO lives on. The ISO, again, is just a exact replica of that CD. And what we're going to be essentially downloading here is an ISO CD image of Linux Mint 22.1. Now you can get a bunch of different types of Linuxes. This is one of my favorite distros, and it's very slick, very sweet, simple, and it's very replicatable to like a Windows environment. So if you're used to Windows, pretty straightforward to actually use. So what's the installation process? We'll go through it as I have before in previous videos, but it's not too crazy, and because we're live, it's gonna have to take a little bit extra time. But we basically choose the ISO we want. We can also verify that image, make sure that the download is not corrupted or some bits did not shift around, mess us up. And then we go to the live booting process. The live boot is where we will take that image, open it in the computer, and then essentially run the system as if we are running it from a CD. That's one of the big pieces that we basically use to install anything. We can install Linuxes, Windowses, all kinds of stuff. And I have my own set of hard drive space dedicated to a bunch of different ISOs. But first case scenario, you essentially want to download one of these. I do have some pre-installed systems, so I'm not going to go through the full process, but I will show you what you need to go through in order to download, install, and set up. We create a bootable media. This is another requirement. In order for us to actually boot from it, in the case scenario, if you're trying to actually install this on your laptop, you will need a USB. That USB will act as a simulated CD, and some options for this are using Rufus. Rufus is a application that will create a bootable USB. Pretty straightforward. You just pick the file, pick your USB, and boom. You can install all kinds of operating systems, and you can run those systems directly from your USB. So if it's Linux Mint, if it's Ubuntu, Kali Linux, you can basically make, or even a Windows system, even Windows recovery USBs can be created this way. But if you're planning on essentially installing your system basically from Windows or whatever you have now, your actual host, we got to really think about the host being the hardware, right? Your physical hard drive, because now we're going to be dealing with guest operating systems, a guest OS that's going to run on top of the host, and you can basically use 2 or 3 or 4 different systems at once. But we'll basically be doing that in order to communicate between the systems. So if you're trying to change your host, then yeah, you will need to create a bootable USB, dedicate some 4 to 8 gigabytes depending on the system. I would recommend 8 to 16. Some Linuxes are pretty large. But you erase that flash USB, you put the ISO on there using Rufus. And what I personally like as far as tools as a techie is the Yumi. Yumi can create multiple, literally as much space you have on that USB. You can put Windows on it, you can put Linux on it. You've even got options. Let me show you what it looks like. So I'm gonna pick my current Yumi installation USB, and this little drop down gives us every single possible type of operating system, which is pretty sick. CentOS, if you don't know anything about Linux, Yumi is probably the best way to really learn it. You can go into maybe CentOS, and then you can visit the homepage, and it'll take you and give you some details about the operating system. And there's tons of different systems. Again, my recommendation is Linux Mint, but, and it should be in here as well, you've got your obvious Ubuntu's, Kubuntu's, there's Linux Mint. And what I do really like about Yumi is you don't need to just do operating systems. Look at how many there are. There's so many. You can also do anonymous browsers. Those are nice. For specific reasons, of course. You can do antivirus CDs. Now, some of these are pretty old links and many of them may not actually exist. But especially when it comes to these antivirus tools, I do use a couple of system tools, Clonezilla, so I can make a copy of my hard drive. Gparted. Gparted is a way for us to partition hard drives, which is something we're going to take a look at during the installation. It's a very interesting but advanced way. You got to be very careful with partitioning, and you have to make sure that whatever you're partitioning as in cutting apart into pieces, if you're partitioning your hard drive, you're splitting it up into multiple locations. So you're kind of giving different drive letters to a single drive so you can separate the sections. So one drive that's 500 gigabytes, you can put 100 gigabytes for one partition, another 100 for another, and basically have 5 partitions between that one physical drive. But this is what we will need to basically set up our Linux system. But luckily, when we install, we have a simple way to do it. Basically, let the installer do it for us, and we have an ability to go in and modify it manually. So we're probably going to take a look at both, but for the sake of simplicity, best case scenario is to let the system do it for you. So Yumi's got quite an option set. I really like this one the most. You can take one USB and put as many different operating systems on it and run them simply by connecting your USB to the device and then rebooting and selecting from your startup screen which device to boot into, which you can basically select your USB. Even then, if you've never touched the BIOS, if you've never touched the internals of a computer and you're trying to do a post boot onto the system, you may run into some restrictions that you have to activate in BIOS. So make sure you know your computer well, make sure you know how to access your BIOS, and you can always look it up online, ask Grok, or any of the other ideas there that will give you more details on how to activate USB boot up, or the ability to select your USB to boot. Alright, so that's kind of the idea here. We're still going to be dealing with our Linux Mint, so I'm going to go back over here. Again, I've already got it installed, so I don't need to do anything crazy other than grab that USB. Or that ISO image from an installed location that I already have. We should have our VirtualBox downloaded already. We do. So this is the installation just for the application to run operating systems on our system. So as basically anything, you just keep pressing next, 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 get yourself to the end. You do have a network interface feature will reset network connection. That should be alright. We need to do that. I don't really like all these shortcuts. I know how to access it directly and so forth. So now it's going to install VirtualBox, which is going to be the host for our system. My mouse stopped working for a moment, but that's because the installation has to create some virtual drivers so that we can still have our physical keyboard, physical mouse, everything still connect to the operating system. A little flicker for the display driver. I'm hearing my USBs connecting and disconnecting. There we go. And of course I probably have to go through. There we go. Give it a moment. So there's a lot of basically integration that VirtualBox needs to do into your hardware. So the installation is not just like, oh, install this application and you're done. It's actually going through all your drivers and creating pathways. So let me have that working itself out. Creating network adapters. All right. Okay, so now we can start it up. There we go. Perfecto. So that's it. Now, in the past, I remember I had to do a reset on the computer in order for it to work. But hey, we're in the future. Plug and play is the thing. From here now, I guess you have a choice. Haven't seen the basic or expert. I've used it pretty directly. But I'll show you how to install using VirtualBox, how to install an operating system that's not your local host. So you can install on top any operating system you want. And it starts off with adding, or new, sorry. In here, I'm going to do the Linux Mint installation. So I'm going to name it appropriately. It's got some presets, so it's going to estimate the closest Linux version, which is Ubuntu. It is what it's based off of. We have an ISO I have it already installed, so I'm gonna basically grab it from my directory of ISOs. Let's see if it's in here. Pretty sure I left it in here somewhere. There it is, Linux Mint 22.1. And this is how ISOs are used. Now you can also mount them as actual CDs, which then you can see the inside files. So if I right click, I can actually mount, and you can see a little CD right next to it. That just basically says, hey, let's actually mount it onto the system, but it won't keep it mounted, especially if you decide to restart. It's not going to stay mounted into the system. It's going to basically reset. So it's not a viable way to install. Again, if you're actually installing Windows or Linux or anything on a laptop, which is a great thing to know, because most of the time, if you ever have a system slowing down, and especially if it's Windows, the biggest fix you can possibly do is make a refresh. A refresh install, which will speed it up back to normal. And of course, making sure you have a backup so that you don't lose your information, documents, and all that. But knowing where your files are is important, because you don't have to back up every little thing, just basically the user folders. So this is a case for understanding a little bit about how the operating systems are organized, right? You've got your Windows system here. Naturally, this is what gets refreshed. You've got your users folder here. Naturally, this is where anyone existing on the system as a user, that's where their files are going to be. And if you back up the users, you basically have all your downloads, images, documents from every single user. Although you may run into some user access issues because each user has permissions and each folder has permissions. So you may have to modify some permissions to access the details. But when you do backups, it's always good to back up the users folder, and everything else can be reinstalled. So here we are, VirtualBox. I'm selecting my Linux Mint 22.1, opening it up. That's going to be mounted as so. Then I'll click next. I have an option to basically put in some details, as in password. Oh, caps lock. That's gonna confuse me. If you have, you know, product keys, if you're dealing with Windows, sure. But we got Linux, so it's nothing related. What else do we need? Linux Mint, install in background, guest additions. You can configure. Linux Mint 1. No, it's not doing my guest domain. Unattended guest. Oh, this is unattended. I don't want that. Skip unattended installation. Okay. Hmm. Uh. Okay, I guess it added an extra. Okay, there we go. So skipping the unattended installation. They've got some new options in here, which not necessary for us right now. Now here's the key to share some of your hardware with your new operating system. You can give it a certain amount of memory, RAM, a certain amount of processors to work with. For Linux Mint, I wouldn't give it too much. I'd probably give it 2 processors and what, 2 gigabytes? That should be decent. And again, this is for an example. This is gonna basically create all the requirements, a virtual disk drive to hold that system once you have it set up. Because you need to install it into something. So what VirtualBox does is takes a small space, or a space allocated here, 25 gigabytes of hard drive space, and then configures it just for that specific system, for the VirtualBox image. And we finish here. Now it's not installed yet. What we have to do is start this machine up. And again, I have all of these already installed, so I'm just showing you the process as quickly as necessary, and then I'm gonna run them directly from my pre-installed images. Here is the startup. This is what you will see, either if you're booting from a regular computer, completely installing the whole system on your hard drive, or if you're running it through the virtual machine. This is the boot up screen. You can kind of tell because it is super tiny, and that's really the resolution supported by a base system without drivers and without extra stuff. So let's start Linux Mint, and this is another way you can run an operating system without installing it. All we've done so far is just configure some backend details. So here's your matrix, here's your hacker style loading screen. Every Linux distro basically starts like this. I think it's pretty neat. I love watching everything go through. Depending on your hard drive type too, if you have a solid state drive, it'll work pretty decently. If you have a MV2, it'll work great, especially when you're doing it as a guest, because right now this window is the guest operating system. My main windows in the background is still the host, right? So if the host system is running on any sort of normal thing, normal hard drive like a actual disk drive, you're probably gonna have much slower uh, response when it comes to this, when it comes to running any secondary system in the background as a guest. And this is it. Look at that. We have our own little, it's not as configured yet, but this is what Linux Mint looks like. This is a new operating system in the guest of our system. Now we can essentially go through here and install Linux Mint on the hard drive we just created for 25 gigs. That hard drive will act as the dedicated space for the operating system, or we can just straight up use the system as it is. I think I should be able to access outside sources. There it is, so I can access Google directly with a ping. I can open up a Firefox, which acts as basically another operating system within my host Windows. And there we go. So now we have at least a running system in the background. The installation process, well, we won't go through that, but at the least you know how to start it up and get it running based on a simplified version of getting the ISO, running your VirtualBox, connecting that ISO to your VirtualBox, and then starting the system up. And from there, there's plenty of tutorials online on how to install. For now, we're going to skip the installation process and we'll get straight to the Python programming. So I'm going to close this down, close here. Because again, if we're doing networking, we need multiple devices. So that is important. So I'm going to reconnect to another drive that I have. Have a bunch of workbenches here from Android to Linux. And there's key pieces here. If you already have and backed up some virtual machines, this is what the actual system looks like. You've got a VDI, which is that virtual hard drive. This one's 20 gigabytes, and it holds the operating system. There's a VBox file that connects your basically double-click associated file to open up in VBox. But what I can do from here, since I already have those, I'm gonna add, and I'm going to go ahead and access that directory, grab my VBox Workbench Linux, open it up, and instead of installing it, this one's already installed. So there's nothing to really go and do other than just start up that system. On the same light, I'm going to also, here's a key to remember: when you're kind of inside, sometimes your mouse gets stuck in the guest operating system. You have a right control on the keyboard to loosen it out. So there's the auto keyboard control, mouse integration. There's going to tell you some details here that your mouse is locked within the window. If you get stuck within your window, use that keyboard control on the right. There's also ways you can modify this. I believe you can go to machine, settings, user interface. And then there's a way for us to, where is it? Auto audio capture, visual state, display storage audio network. So this is the actual virtual machine settings. And there was a way to use or change the mouse exit key. Full screen, interface, but I can't really remember where that button was. I've used it once or twice in the past. But basically you can, from here, configure any storage related to it, any display drivers, monitors, graphics card dedication for video, audio connections, network connections, USB filters. So you can actually attach USBs on your device, your host Windows, and then connect it through here so it kind of bypasses through your host and goes directly to the guest. That's also a nice little feature. And you can create shared folders between your main system and your guest. But that's it. I'm not finding it right now, but that's fine. I think discard changes. Am I missing? Preferences. Maybe it's in preferences. Hold on. It's important to know this. Interface. Follow. Disable host screensaver. Check for updates. There we go. Host key combo, right control. So this key here that you can change in preferences, right now by default, it's always on the right control on your keyboard. When you press that, you let your mouse basically leave the guest. But sometimes when you first install a system, it doesn't have that integrated, as in automatically leaving. You can see right now I'm entering and leaving the window, but my mouse disappears when I enter that space, especially over here. Quite some time on the installation process here. I might have to reinstall Linux on. But being able to modify that key is useful because then you can, for some laptops, they don't have a right control button. So that would be kind of against us. Maybe I have too much stuff open. Let me see. Clean up some background processes. Also, I don't know how much hardware I've dedicated to this sucker. Let me get rid of Steam. Libre, we're done with you. Slack, don't need right now. Yeah, I kind of have a lot of stuff open in the background. Always good to clean up your system before, because it does take quite the amount of memory to run. But also the other one worked out pretty well. But then again, it could be because I'm using this from my secondary hard drive, so that might be a problem. Even though it's solid state, technically the current Workbench Linux that I have running is on a solid state external hard drive. So that might also be the dilemma here. It might be slowing down the process, but okay, it's adjusting. I'm seeing it load up. Now in the process, let's add another one. Let's do a Windows 10. Gonna add that from here. And these are essentially not ISOs anymore. Oh, but then again, where is... Oh no, it's gone. Hold on. None of these are actual files though. That's the problem. Hold on. Because we don't see a large size here for the actual virtual machine, so I don't think that's going to start. I think I messed that up somewhere. I have an XP2 in a Windows, but I probably moved it somewhere else. Might have to do an XP. Back to the old days. Or a Windows 7. Let me remove this. It's not going to work. Once you have it installed, though, you have this set of files, the VDIs, which is basically useful for you. You can copy it as well and make an exact copy of the same system twice, which basically gives you the ability to play around with an operating system however you want. And if anything breaks, you have a copy, you can just delete the old one and refresh the new one. Or delete the broken one and refresh with the copy, and you can keep going about your day. So virtual machines are very, very good for experimenting, playing around with the components of the operating system. And if you break it, then you learn. But in the process, you can also have a backup so you don't have to worry about that. This might be a little bit of a unforeseen problem at the moment. I might need to make some local versions, which means I might have to take time to copy and paste and move some stuff around. If it's running from my local hard drive, it'll be way faster. You saw how the Linux Mint was doing. Which means I'm a little bit unorganized with my files. That's what it means. I need to get more organized. But anyway, let's get down to some coding because I want to show you what and how networks can be done, or network communication on a network with Python. That's kind of the key here, is being able to consider how do I make a server, for instance, directly through Python. Which means I might have to kill this machine. Hold on. Because it's acting up a bit. There we go. All right, let's get to the code. So let's see, where is my network space? Firewall. Networking. Client TCP, UDP. I'll make a new one here. I'm gonna call this base server.py. Now, networking requires a decent kind of understanding of sockets, these virtual protocols that help computers communicate with each other. Luckily, Python gives us a pretty straightforward way to access socket control. If you do it in C++, Java, that's also possible, but most cases you have to do more manual programming in order to get the sockets to work right. But lo and behold, in Python we just import a package called socket. So this package is going to contain everything we need to basically communicate on the network, so long as we know what we're doing. For us, we're basically going to create a loop that will run a server and listen for information on that port. That's it. This is actually very useful too in network security. In the case that you may have a scan, if you're in a business environment, some scanners will try and scan every single possible port available to find out what's open, what's not, and basically do reconnaissance on your network or on your server or PC. So having this sort of mini script running in the background, you're able to hear what is happening on those ports. In our case, we need to first create our function by using a definition here, def run server. This is going to be the startup to our loop, but we got to set up some socket info first. Let me zoom in a little. Now, what we need to do, we need to create a variable just to store the information for our socket. We'll access that socket import, which also inside there's another socket method. And using some built-in socket variables that we don't need to know about, af._inet and socket.sockstream. This is kind of like where the manual aspect of using C++ and Java is broken. You don't need to know how to create a socket stream. You don't even need to know how an internet system works. But these are variables that contain some pre-configured systems or attributes for our current socket application. We have to set a server address. We'll use a pair here to set this. Now, when we're pointing to ourselves, like I want my system to be the one listening, we use a specific number, a specific IP address. There's a couple of ways you can kind of consider what a computer references itself on a network. One is localhost, just the typical key or typical word localhost. But it's not really IP configured, and depending on whether we're going so down low to the bare bones of a socket, it doesn't necessarily translate directly to the meaning of localhost. The meaning is a number that always references the system currently talking on the network, and that's 127.0.0.1. This IP address is normally a reference to yourself. So if you're running an application, let's say a web app locally, maybe a Python is creating a server interface, you go to your browser and you can type 127.0.0.1, then you can see I've kind of have a couple of past applications I've used, like a PHP server that runs under the 127.0.0.1, a MySQL server that also runs under 127.0.0.1. That's how you reference a specific internal IP address. Now, if I do this now, I don't think I have anything running, so nothing is actually going to happen. Unable to connect. There's just nothing running on my server locally in order to connect to it. But we're going to be using this as basically telling the program, hey, I want to basically listen on my local port. We can also use 0000. And from here, the IP address is another case for referencing self. It's like when we use I in a sentence. A computer uses 0000 or 127.0.0.1 or localhost. All of those are just keywords for I, the thing that is currently working or connecting. Then we have to tell it what port to listen to. So we're going to set up, in this case, port 10,000. That's going to be the specific port we want to listen to. In the process of us running the server, we want to give the user a little bit of info starting on, this is a placeholder for a variable. These curly braces are just basically placeholders for the format function. And we will give the information here. The format will split the server address information. The first goes here, the second goes here. Just notifying what's going on. This is just a typical conduct you do as a programmer, keeping information printed so we can see what's happening in the back end. Now we're going to take this socket we created, and we're going to bind it to this info, the server address info that we just created, which is going to take that address and that port, and now it's going to configure the current AF, INET, and socket stream to start listening on that port. As it's running, we want to create a loop that continuously goes in circles. So it's just a straight up true. This is how you make an infinite loop, but if you don't break out of it at some point. For us, we just want to basically run this in the background continuously and listen on that port. So I'm just going to give myself again, waiting on connection, a little bit of info for the terminal. Now, when we find a connection, when someone pings us, connects to us, has even a scan, because again, a network scanner, a port scanner, like Nmap, which we will use in a little bit, will go through every single port unless specifically told to go to one number, and it'll send data to that port. That's how a scanner works. A computer has about 650,000 ports. No, sorry. No, 65,000 ports. I'm off by a zero. And normally the main ports are 80 for HTTP, 21 for SSH, 8080 for HTTPS. Basically, all the normal protocols we would use to connect to the internet, there's specific places that that data goes to. Think of a port as a door into your computer. And if you really think about it, the computer has 65,000 doors, which is a lot. So we basically want to catch any of these scans with a connection and client address. This is the return from our sock.accept situation. So something gets caught on the port that we're listening on, port 10,000. Then this activates and gives us who messaged us or who sent us information on that port, and then the connection involved. Now, for here, because not every single loop is going to give us info, meaning that while the while loop is going, we may not have anything happen on that port, we use a try and a catch, or in this case, finally. Try something, and if it doesn't happen, skip it. What we want to do is we want to try to find if we have a connection from the client address. We want to grab the message that it's sending from the connection, and we're going to receive a couple of bytes in here. When we're dealing with data, when we're dealing with computers, we're basically dealing on the 2 to the power of x increment. So we either have 2 bytes, technically too small. We got 4, 8, 2 to the 4th, 64, 32, 128. All of these numbers should be kind of familiar based on if you play around with like hard drives, if you know the sizing of a hard drive. 1 gigabyte would be 1024 megabytes. It's not exactly 1000. There's this extra value in there. This is just the way computers work, that digitally everything runs by twos because of the binary nature of zeros and ones. So in our case, we need to basically grab, or we want to grab about 1024 bytes from the connection being made. We'll go ahead and print that out using a catcher here. So we take the message, throw it in the variable here. We can also give it a response on the other side. I like to just do this for whatever reason, but we can basically put whatever message we want to return to the other computer. They contact us, we get the data, and then we give back a response. It's a two-way communication factor. Now, this is how you make connections happen. When a scanner happens to fall on an open port, it will send some bytes, maybe a specific set of bytes that that port is looking for. If it's an email client, it's going to look for a specific set of commands that come in from the port. Same thing for HTTP, for UDP, TCP, all kinds of different specific sets of code So every time we get a scan or get a ping on a port, we return something. And many security scanners will look at what was returned and identify, oh, is there an application active? Oh, this information that I got returned is coming from Outlook or from Thunderbird, if it's an SMTP, or from a browser. So the response and communication is always two-way. You send info to a port and you receive a response from that port. Both cases are for security researcher important because depending on what you send, you may get something specific that you can identify, like what operating system it's running in. All kinds of little details that can be found out. But for our case, we're just sending back a little bloop just to show that the information was sent. Finally, on that same connection that we have saved in the variable, we're going to send all our response back to it. Well, not finally, that's in the try. So we got to recall that if we're trying this out, there's a case where it's going to fail, where we're not necessarily going to grab anything. And after it's done, we're going to go ahead and close the connection and keep listening. So we will send info. After we send it, we're going to close the connection and then keep listening for another connection. And that's basically your server. That's it. That's all it takes. We need to configure what the server addresses will be. We need to create a set of, well, no need to do this at all, but for us to know that the server is running, we need to print out the information just to show ourselves that everything is running fine. Debugging, if you will, informatory, in another case scenario. We want to bind our information to the server, to our socket, and then basically wait for an accepted data set to come through that socket. Everything else is basically just printing and showing and responding to that data. Now, we don't have it running yet since the function has been created but not run, so I'm just going to put in a little run server, and voila. So now we're going to run this sucker. Let me see, self-accept, socket line, invalid argument, let me see. Sock bind, sock accept, inline 24, 12. A little debugging here. So yeah, we got the data and the address, self-accept line and accept invalid argument. I wonder, this might be a... No, not in here yet. Could be a firewall issue. It could also just be that I'm running it through Visual Studio. Sometimes it doesn't do a very nice way for us to work with. It has a limited set of capabilities, so I'm going to reveal the path, grab my location, cd into it, or first I, there we go, and let's do a Python base server here. No, invalid argument was supplied. Missing something, hold on. Wait, hold on. I'm missing something, yeah. We have to activate the listener. Forgot to activate the listener. We have to basically listen on an increment of time. Now that should be enough. Because in this case, the accept doesn't exist until the listen begins running. So there's kind of a conflict. Why is this accept there if we haven't started to listen yet? Alright, there we go. So now it's listening. How do we activate this? Well, we need a small application called nmap. Mm, I did use it before, so I might have to reinstall it. Let me see. I have it somewhere. Did I not install it? No. Okay. Well, that's a case for us to install a little networking tool called nmap. Great little tool for network analysis, seeing what systems are running, making sure your own system is secure, that you're not giving out too much information on the network. I swear I had this installed, but I think I reset some stuff, so that makes sense now. It's a pretty small package application. Oh, but maybe I can ping it. Let me see. Ping 127.0.0.1 at 10,000. No. About 0.0.0. Nah, it's not gonna work out. So nmap is gonna help us have some extra little tools for networking. I can't do it from another computer, but I would beat the purpose of showing what happens exactly. There it is. So now nmap's installed. Always refresh your command prompt when you install new commands. Now I can do a nmap local 10,000 ncat 2, that would have been nice. Ncat would have been a nice one actually. Ncat, does that come with it? Yeah, okay. I guess ncat comes with nmap, that's nice. So 127.0.0.1 resolve hostname, no such file known. Let me make sure that my firewall is not blocking stuff. No, it looks fine. Check something real quick. I didn't format that correctly. Alright, that's gonna be ncat, the IP address, the port, and then text, right? Got more than one port specification. Oh, right. No, it's just straight up like this. Okay, there we go. All right. This is where I actually send the information. So ncat is basically connected to that port. We do see that connection happening right there. Now, what can you do with this? Well, basically like a regular text messenger, right? So there's the received bytes. That's the information sent from the connection on that port. And then the response, bloop, being sent back. Now for the case, we can potentially also do an input from the user, comment this out. I gotta reset that server. And then reconnect again on this side. Now here I should be able to return text. Object required, not str. Alright, well I have to basically, hold on. Okay, I can package it. It should be at least. Bytes like object required, not tuple. Ugh. A little bit more complex. Oh, converting to B from here. I guess this byte type is being well converted, but I'm not sure how to convert the input stuff. So for now, I guess that'll be it. But in the end, we kind of saw how we have to create a socket on a specific port and IP. And we've created essentially a basic server. Now from here, converting that data that we get into PHP, HTML, then it becomes more of a specific set, because websites basically use HTML servers, PHP servers to host the code behind it. They return the HTML document, I misspoke. And then the communication on that port is what becomes your web-based access. And this is as simple as it gets as far as Python. Of course, we're not looking at the very intricate details about an intranet, about a socket stream, about the other details involved. And that's it for now. I just wanted to kind of go over a little bit on that. I have to really set up my virtual machines to show that I can go on a different machine and still do this ability here. That's all I really wanted to use virtual machines. So I can say, hey, machine 2 is going to act on an ncat send to machine 1 that's running the server. And then we can still see this sort of pattern between these two pieces. In the end, this works both locally and through different machines on the network. But based on your network topology, it could be a little complicated. You may need to go through firewalls. You may need to restrict or access or open certain ports, like in this case, port 10,000. But we've also potentially, if you've seen previous videos with Greyhack, we've seen how we can use ports to forward information to a whole different computer or IP or value set. So port forwarding is a very powerful way to give access to certain applications that may be behind a router firewall. Anyway, for now, I think this is enough and sufficient. I still got to set up some more lab stuff on the networking side, but this is kind of a good point to consider. It's not too crazy hard at least, to create your own local server and then expand on it, because now we just have to analyze the responses, the inputs, the connection message, and then forward to really make it a PHP server or make it a AI server at this point, because they run behind a server as well. But this would be a case where now you have an application listening on a port which you can communicate from the outside on a totally different application. So this Python server, if it's built into another application that you have, can now accept information from PHP, from Java, from C++, C Sharp, and you have a full set of communication between different languages. So you're not really restricted to basically using just one language to program a full tool or a full applications. You can mix languages, and then you can let them communicate through a port or through something as simple as a JSON file. But ports will be a lot more on the reactive form, because they're listening on a constant basis and they're going to react as soon as that port gets scanned. For a JSON file, the file has to refresh. You have to keep scanning and seeing if there's any changes on the file, and then you'll know that something happened, and then you have to read the file and see what changed from before and do whatever actions you want to take. But a port is a lot more live, and it's able to act exactly on the moment of something happening, some connection happening, some details expanding. But for now, that's all I got. I do have to do a little bit of organization. We're going to expand on networking for sure. It's one of my favorite subjects to do, especially for the security aspect of things. But I wanted to kind of go over, from everything else we've done, a little bit of networking, because it's a good little flavor to have with everything else to understand how the whole ecosystem of applications work, not only separately, one application and then a different one, but how you can create some sort of medium for communication. And C, C++, Java, Python, Lua, all of them have the ability to use networks. They have it as a built-in package or on the side where you have to import it. And ours was Python, where it was a package we had to import. And then from there, we created our server, made it listen on a port, and then accepted information on that port, where we can basically test it out manually. I'm gonna remove this again and put bloop again and show that again. And running here, connected on the port, use ncat to connect directly to that. You see the connection pop up, test. There's our test received from our port, and didn't receive anything back this time. Did I mess something up? Oh no, because I have this. Oh right, I have to finish it off. There we go, bloop. Now, two-way connections can happen between applications, and you can configure if-else statements to basically say, hey, if they did something, if they sent something, we can return something else. Anyway, thanks for joining. This whole video will be posted, and I will do some cutting, because when we're doing live stuff, we get a lot of me thinking or me troubleshooting or debugging. But I'm going to reformat it to about a 10-minute video, hopefully, and put it up as a upload later. But if you're new here, please like and subscribe if you like this kind of content. Everything from programming, artificial intelligence, sometimes gaming, a lot of math. But I make sure to teach you how to work with these things so you can become a better, well, a brain lifter, I like to call it. We like to lift with our brain here, get them brain cells firing up. And of course, sometimes I might pop up and do some sort of like current event thing, because it's got me fired up, so I am still human. Yeah. Anyway, thanks for joining. Appreciate your company, and say something in chat once in a while. Sometimes we get some active users, sometimes just watchers, which is fine both ways. But remember, you can get your questions answered just by asking them. I'm open to asking any questions, especially during office hours. This is kind of a short little video or stream, but in the future, keep an eye out for office hours that I put out, where I take all kinds of questions, information from you guys, and answer them, go into detail, whatever programming language, PHP, Java, JavaScript, Python, Lua, artificial intelligence stuff, creating images, audio, basically anything computers. Heck, we can even go over a whole session on how to build a computer yourself and what to look out for. So, as far as the technical mind, I am here for your usage, and If you have any questions, you know, make them known. I'm here to answer anything you have. So, that's it for me. I'm probably gonna drink some more coffee. Get another little set of details that I can put into a next video. I might go again today. I might kind of split these up into pieces because, I don't want to kind of go into a silent mode where nothing's happening. So I like to kind of split them up into pieces. Like we did networking now. We might go back to some vibe coding later with some AI. I wanted to make a 3D game with Grok and see how that works using 3JS. So that might be interesting. I kind of tried it before where you walk into different rooms and Grok did a pretty good job, but now 4 is out, so I want to see how he does on this case. But using an AI, even locally, can help you program and learn. And that's kind of the focus. I wanna get anyone able to start somewhere because I know programming is kind of like a foreign language, right? It's not really, it's a logic sense, it's a sense of how to combine pieces. But I also have the streams and the videos based on the first 15%. When you know the first 15% of programming, the rest is just how you put them together. That's it. Anyway, thanks for joining once more. I keep on rambling sometimes. Appreciate the time that you spent here, and